All right, now we're going to work a couple of examples. So first we're going to find the slope between the following pairs of points. So our first pair point is 6, 4, and negative 7, 1. Now there's two ways we could find the slope. We could plot these on a Cartesian coordinate system like the one over here and use a counting argument to count rise over run. Or we can use our slope formula. Remember, our slope formula does the same thing. It gives us rise over run, but it does so by looking at the rise as the difference in y's, y2 minus y1, and the run as the difference in x's, x2 minus x1. Let's go ahead and use that to try and calculate our slope here. So our slope is going to be y2 minus y1 over x2 minus x1. 1 minus 4 is negative 3. Negative 7 minus 6 is negative 13. Negative over negative is a positive, so our slope will be 3/13. Now we don't need to simplify that because it's already simplified. This doesn't reduce. So there's our slope there. Now let's look at our second example here. So we're asked to find the slope between 3/2 7 and 3/2 negative 2. Now, if we're just going to go ahead and plug into our slope formula, that seems like a logical thing to do. So I'll do y2 negative 2 minus y1 7 over x2 3/2 minus x1 3/2. Negative 2 minus 7 is negative 9. 3/2 minus 3/2 is 0. Uh-oh, we have division by 0. What happens when we have division by 0? Well, this quantity is undefined. That means our slope is undefined. So our slope is undefined. And just as a reminder, what types of lines have undefined slope? Well, vertical lines, so straight up and down lines. So this is the vertical line that's happening at 3/2. So this would be the vertical line, x equals 3/2. But the thing we were asked to find, our slope, is undefined. Okay, all right, let's look at our next example over there. Okay, so for the linear graph, so this graph here, we're asked to do several things. Find the slope, find the y-intercept, find the x-intercept, write a formula for the line, and estimate the zeros of the function. Let's see if we can do all of those things from our graph, okay? So first, we want to find the slope. Well, to find our slope, we can use a counting argument. We can think of slope as rise over run. So our m is rise over run. And I can identify 2 points. Here's one, and here's another one. And I'm going to use a counting argument to find my rise. So my rise, I go down 1, or negative 1. And then I run 1, 2, 3. So my slope is negative 1/3, negative 1 over 3. So my slope is negative 1/3. Our y-intercept, remember a y-intercept is where the graph crosses the y-axis. That's that point here. So that's at the point y equals 1. As an ordered pair, that will be the point 0, 1. Our x-intercept is where the graph crosses the x-axis. That's right here. At the point x equals 3, as an ordered pair, that will be 3, 0. All right, now we need to write a formula or an equation for this line. Well, the easiest formula we have is mx plus b, our slope-intercept. As long as we know our slope and we know our y-intercept, we can write the slope-intercept form of this equation. Well, we know our slope, it's negative 1/3. So this would be negative 1/3 x plus our y-intercept. Our y-intercept, that's not our y-intercept, that's our x-intercept. Our y-intercept is 1. So negative 1/3 x plus 1. So there's our equation, negative 1/3 x plus 1. Well, technically f of x equals negative 1/3 x plus 1. Class, we're asked to estimate the zero of the function. Remember that 0 is another way of saying x-intercept, okay? We don't even need to estimate the 0, right? We know exactly what it is. Our 0, our x-intercept, is at 3. So our 0 would be at 3, okay? Let's do a couple more examples. All right, 2 more examples. So first we want to write the slope-intercept form of the equation for a line passing through point negative 2, 7 that has slope negative 3/4. Okay, so remember, slope-intercept form is going to look like y equals mx plus b. Okay, well, we know part of this. We know our slope. We know that our slope, our m, is negative 3/4. So here's our m. Now, I'm going to show you two different ways to do this. Either way is fine. You pick the one that you like best. Okay, so the first method, okay, is just to go straight to slope-intercept form. Okay, so what do I mean by that? Well, we know that our slope-intercept form is y equals mx plus b. Okay? Right now, we know our slope. We know that our slope is negative 3/4. So I can substitute that in to get y equals negative 3/4 x plus b. Okay? Now, what else do I need to know? I need to know my b. Remember that our b is our y-intercept. Unfortunately, this is not a y-intercept. How do I know? Well, remember that a y-intercept has x-coordinate 0, and this does not have x-coordinate 0. So this is just a random point on the line. That's fine. It still is an x and a y, right? X negative 2, y 7. If I substitute those values in, make this y 7 and this x negative 2, then the only thing I won't know will be the value of this b, and I can solve for b. So let's try that. So I'm going to let my y be 7. So I'll have 7 equals negative 3/4. I'm going to let my x be negative 2. And now notice that the only thing I don't know is b. And b is what we wanted to solve for. Okay? So 7 equals negative 3/4 times negative 2 plus b. I'm going to solve this for b. To solve for b, the first thing I'm going to do is combine negative 3/4 times negative 2. So negative 3/4 times negative 2, oops, sorry. I'm doing this, negative 3/4 times negative 2 over 1. Negative 3 times negative 2 is 6. 4 times 1 is 4. I can reduce this by dividing top and bottom by 2 to get 3 halves. Alternately, you could have simplified first. I have a 4 and a 2. So when I cancel that, I'd be left with a 2 and a negative 1. Negative 3 times negative 1 is 3. 2 times 1 is 2. Either way, I get 3 halves. So I'm left with 7 equals 3 halves plus b. Still trying to solve for b. To solve for b, I need to subtract 3 halves from both sides. So I get b equals 7 minus 3 halves. In order to do that subtraction, right, I actually have to get a common denominator. My common denominator is going to be halves. In 7 wholes, there are 14 halves. So 7 is the same thing as 14 over 2. 14 over 2 minus 3 over 2. If I have 14 halves and I take away 3 of those halves, I'll be left with 9 halves. So altogether, my equation is going to look like y equals, my slope was negative 3/4 x, and my intercept was 9 halves. So here's the equation in slope-intercept form. Now I said I was going to show you 2 different ways to do this. Another way to do this is to use kind of one of the other forms we have as an intermediary, and that is that point-slope form. So we don't want our final answer in point-slope form, but we can use point-slope form to get where we need to be. Remember, point-slope form says y minus y1 equals our slope times x minus x1, okay? And that point-slope form is really useful for when we have a point, like negative 2, 7, and a slope, which is exactly what we have here. So if I use our point-slope form, I'll have y minus, my y1 is 7, equals our slope, negative 3/4 times x minus our x1, negative 2, okay? Now, that's a perfectly good equation, but it's not the form they asked for. They asked for slope-intercept form. What we can do is we can go from point-slope form into slope-intercept form just by rearranging terms. So basically, I need to get y by itself. So I'm going to do some simplifying over here. I have y minus 7 equals negative 3/4 times x minus minus 2 is x plus 2. I'm going to go ahead and distribute that negative 3/4. Y minus 7 equals negative 3/4 times x is negative 3/4 x. Negative 3/4 times 2 is negative 3 times 2, which is negative 6 over 4. which is negative 3 halves. And last, I need to add 7 to both sides. So I end up with y equals, I need to combine negative 3 halves and 7. That should look familiar. Okay? Negative 3 halves plus 7 is the same thing as 14 halves. Negative 3 plus 14 is 9. So when I combine those, I'm left with y equals negative 3 halves x plus 9 halves. Notice we got the same thing with either method. We got the same slope-intercept equation. Either way is fine. Do whichever one you feel makes the most sense. Okay? All right, I'm going to erase, and then let's look at our other example there. So now we're asked to sketch a graph. We're going to sketch a graph, and it tells us, hey, use the intercepts to graph that linear equation, 2x minus 3y equals 12. Now that is an example of a linear equation in kind of the third form that we talked about. And that third form is standard form. So this is a linear equation in standard form. Okay. And in the example we looked at with standard form, we saw that it's usually pretty easy to find x and y intercepts in standard form. So let's do that. Let's start by finding our x-intercept. How do we find an x-intercept anytime, anywhere? We can always find an x-intercept by setting y equal to 0. So I'm going to take my equation, 2x minus 3y equals 12, and I'm going to set y to 0. So 2x minus 3 times 0 equals 12, and then I'm going to solve for x. Well, 3 times 0 is 0, so I'm just left with 2x equals 12. Dividing both sides by 2 gives me x equals 6. So my x-intercept is at y equals 0, x equals 6. As an ordered pair, that looks like 6, 0. Now let's find our y-intercept. Well, how do we find y-intercepts anytime, anywhere? Well, we set x equal to 0. So in my equation, 2x minus 3y equals 12, I'm going to set x equal to 0. 2 times 0 minus 3y equals 12. 2 times 0 is 0, so I'm left with negative 3y equals 12. Dividing both sides by negative 3, I get y equals 12 divided by negative 3 is negative 4. So my y-intercept is going to be at x equals 0, y equals negative 4, which is the ordered pair 0, negative 4. Now, I have 2 points. Remember that 2 points is enough to sketch a graph of a line. So I'm going to give us a little Cartesian coordinate system here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to plot those 2 points and connect them together. So my x-intercept was at 6, 0. 1, 2, 3, 4, 5, 6. Our y-intercept was at negative 4, 0, negative 4. 1, 2, 3, 4. And then I'm going to connect them with the straightest line I can draw. And there we go.